In this video, I'd like to go over one of the very common pitfalls that I see people who are new to Python and Houdini fall into, namely the problem of editable nodes or unlocked nodes. So, to give you an example of how this problem manifests itself, I've made this very simple read and write node. All it's intended to do is write out geometry that's plugged into it and then read it back in. So, in the HDA module for this node, we have a function that gets the path from a template that it creates, and then a function that renders, and the render function will just create the directory if it doesn't already exist, and then it'll run the execute functions callback here. And then we have this render button here whose callback runs this render function here. So it's pretty simple. Now, the problem is that on this node and on this node, for the parameters that deal with the files, we need to get this path here. And this path is generated by our Python function. So the simplest way to do this is just to create a Python expression here. So if we just change the default language of this node to Python, Alt-click to create a keyframe so that we can set our Python expression on a string parameter. Click into the parameter and hit Alt-E to bring up the edit expression dialog. And then we can say something like parent node equal who.pwd.node ... So who.pwd returns the current node, and then we're getting a node that is relative to that node. And our relative path is ... so it's going to go up one level. Another way that we could do this is who.pwd.parent. Same thing. Regardless, parent node is going to be set to the read-write node. And then we can say return parent node.hda module .get path. And notice that the way I have this set up, you have to pass in the read-write OTL as an argument to the getPath function. So let's just do that. Parent node. And there it is. So now if we hit apply, here's the path that it should be written out to. And then on our file node for reading the geometry in, we need to have the same expression. So I'm just going to bring the edit expression dialog back up so I can select everything. Copy, go back here, make sure expression language is set to Python, Alt-click, click inside, Alt-E, and paste, and hit accept, so that we get the same path. So now if we come back up here to our read-write node and save operator type, I'm just going to minimize this real fast, change the path keyword to say fon, so it errors because that doesn't exist already. And then we hit render. It renders the frame range, and there's our sphere. And if I go to my Windows Explorer here, you can see that it created this fon folder, and here's all of our BGOs. Okay, so that's easy enough. But what if I bring the type properties dialog back up, what if this getPath function doesn't evaluate really fast? So what if, for example, we're getting the path from a database or something? So we want to cache the path somewhere because it takes a while. So I'm just going to artificially simulate this. If we just import time here. And then before it actually returns, I'm just going to say time.sleep 0.5. So I'm going to pretend that the path actually takes half a second to retrieve. So now if I hit apply, I go into here and I change my path keyword to Zorg. Notice that figuring out what that path is actually takes it a really long time. every time I select one of these nodes. Suddenly it's really slow. And if it was even more than half a second to retrieve the path, this would be really painful. It would make our node really painful to use. And you can imagine that a node like this might need to retrieve the path in more than just 2 places. And so suddenly evaluating those expressions is very, very heavy and very, very slow. Additionally, if we're trying to get the path from a database, it's even worse because then we're doing way more database pings than we actually need to. So how do we solve this? Well, this is where some people can fall into a trap, and most people do. So the temptation is to create another function to use as a callback. So we'll say def path keyword callback who node. And then if I go inside here, delete this parameter, Control Shift click to delete that parameter. Then we'll just leave these alone. And then what our callback is going to do is it's going to get this node first, so the writeout.go node. Out node equals who node dot node writeout.go. And again, we already have our read write OTLs node object there. So we're just going to get a relative path, and our relative path is just writeout.go. So that should be this guy. This parameter is called sop output. So then the temptation here is just to directly set that parameter. So what happens if we do that? We can say out node.parm sop output dot set first we need to get the path, so let's just say path equals get path who node. And now we can set it to that path. And then we can get the read-in geo node. So say read node equals who node dot node read in geo. And then just say read node dot parm. That parm is called file dot set path. Okay, and then we hit apply. And then the next thing we want to do is just go to our path keyword, and we're just going to change the callback script language to Python. And then do kwargs node.hta module dot path keyword callback node. And hit apply. So now if we change this path keyword, say to blorg, yes, it takes half a second to get that path, which is the minimum amount of time that it can take, but now our paths are set. So what is wrong with this method? It seems to work pretty well. All we're doing is caching the path information on parameters. In fact, you could even cache it somewhere on top of this level as well, which ends up just having the same problem that we're about to discuss. So if we save operator type and we match current definition, what happens when we change this path keyword to something like Zorg? Traceback. Failed to modify node or parameter because of a permission error. So the problem here is that we have a locked OTL. So notice that all of these parameters are disabled. But we're still trying to set parameters inside. That does not work. And here's where people start to run into trouble. Rather than trying to fix this code to work inside of their locked OTL, they instead decide, well, it works when it's unlocked. So if I go over here to this basic tab, I remember that I can set editable nodes. So I can say something like write out. Actually, we can even pick them from the list. So if we open that up, these are the two nodes that we need, so read in geo and write out geo. And now if I hit apply, come up, save operator type, and match current definition. I go inside here, this is still open. This is still open. So now when I change my path keyword to fawn, no more error, and my paths are set. I'm done. It works perfectly. There is a major problem with this, and it will come back to bite you, I promise, if you try to do this. The problem is, if I release this and then someone puts down a read-write node, and say their path keyword is spam, so it's erroring because this path doesn't actually exist, which is what we want, but you'll notice that the paths are set up correctly. Now what happens when I'm looking at my OTL and I realize that I forgot to promote the frame range that it's supposed to write out. So I decide, okay, well I'm going to go ahead and unlock this OTL and bring up my type properties dialog. Go to parameters, and I'm just going to bring in this start end increment and hit apply. Now I come back out, I look at this node, well there's my frame range, so that's great, but notice what happens when we go inside here. No channel references on this. So this person who already had this node down tries to change it to be 120, so it'll render 1 to 120 instead of 1 to 240, and it didn't update. Now the only way for them to get that reference back is to put down a completely new read-write node. And plug that in, and then use the same path keyword. Now you might be thinking that that's actually not that much work to just add this path keyword back in. But imagine that there were several hundred of these read-write nodes in someone's zip file, and it wasn't just one parameter, it was 10 that they had to set. Suddenly they have to set 1,000 parameters, not to mention copying 100 nodes, just to update this simple channel reference that you added. And then, suppose that you realize, oh, I didn't update, or I didn't promote these script parameters, so now I need to do that. So you promote them, save the definition, and then they have to update all their OTLs again. And there are ways of making this easier on yourself using Python, but generally speaking, this makes for some incredibly complicated situations. So what we're going to be looking at this week is some ways around this, so that you don't have to unlock nodes inside of your OTL. So you might be looking at this and thinking that I'm telling you never to use editable nodes, or there's even another way to do it, which is you tell it not to save contents as locked here. And that's actually not true. There are very legitimate uses for that. Generally speaking, you should only use editable nodes or unlocked nodes when you do not care about any of the parameters, the values of any of the parameters on that node. So if I had, for example, a paint sop in here that allowed us to paint onto the geometry, this node, I don't care what the user sets on any of these parameters. My system can handle any value, generally speaking, if we're using a paint sop. So in this case, this would be a fantastic use for an editable node, because then they could go inside and they could change the paint parameters. For the unlocked nodes, the most common use that I've seen for that is generating large networks inside of them. So an unlocked node, just to show you what that does, if we make a subnet and then we say test unlocked nodes, and then we say create digital asset, just get rid of that, copy, put it in my OTLs directory, paste, and accept, and accept. So if we turn off save contents as locked, hit accept, you'll notice that it turns to this sort of lighter blue color. If you can see, this is a slightly darker blue. It's in bold. And what this means is that this OTL is always unlocked, essentially. So you can go in and you can always change things inside of there. Again, it's a really bad idea to use this to allow yourself to set values of parameters inside, because users can go inside and just delete those nodes, or they can completely change things around. And again, you still have the same problem that we had up here, where someone puts down a node and then you change something, and then they didn't even do anything wrong, but suddenly their node is completely out of date. So when would you use this? Well, you might have a button here that generates a network of nodes inside for your user to play around with. Or you could use it as a very simple way to transfer networks from hip file to hip file. So you could save this node with a network inside that you want your users to modify, and then that's a great use for unlocked nodes.